Welcome back everyone to another video, and in this one we are taking a quick look at a cool little battery health tester I bought some time ago off of Amazon. This is, I don't know if it has a particular name that people can search it from or stuff like that, but it's for lithium ion 18650 cell tester, and it tests them individually. We'll go through a few of the few features, but as you can see, I've done a little bit of a mod here to get it powered over USB PD. So there's a USB PD board, and here's a 5-volt converter. I'll show you guys all of that in a second. I bought this because I had a bunch of spare 18650 cells remaining from previous power bank repairs and portable speaker repairs, and I wanted to test them if they are still usable, even a little bit, or should I just throw them away. And I saw this on Amazon, and I just bought it instinctively. So how this works is it will charge fully and then discharge multiple times each cell, as many as you want. So it shows loop here. So this is loop 2. It'll do it twice. It'll charge it fully, discharge it, charge it fully, discharge it, and then charge it fully finally. And that's how it works. So as you can see on channel 2, this is on status as discharge. So it's currently discharging that cell to test it out. And it's currently at 1068 mAh. On cell 3, it's charging it back up. On cell 4, it's on the last loop and it is charging it back up so that it can discharge it again. And on the first channel, on the first LiPo, it's on the first discharge session. So still on loop 2, but it's discharging and it's at 500 mAh. And let's take a look at one of the more degraded cells, like the channel 1, channel 4 cell. It's only at 396 mAh. So this is like really bad. It's at 2600 mAh. It's rated at 2600 mAh, and it's currently just outputting or storing 300 or close to 400 mAh. So this is like really bad. What it also shows is internal battery resistance. So you can see 94 MR, so that's micro ohm, and usually it should be less or around 50. Towards 100 it starts degrading, towards 200 it's bad, anything above is like really bad and you should use that. Internal resistance of 18650 also work a little bit different than most let's say lithium polymer cells like these. The battery protection circuit here is not as complicated, but on 18650 it's almost like a full grown charge control that sits right at this notch. So if you see any 18650 that doesn't have this notch towards the end, so all of these have this small indent towards the positive terminal. If you don't see that, that means it doesn't have any inbuilt battery protection or has very minimal battery protection. But on the internal resistance on a LiPo pack is much more sort of transparently measurable than on an 18650 in my experience. But anyway, these are all bad cells. These are all really old cells, and because all of their internal resistances are like very close to 100, so they are okay for maybe testing something. This one's really bad. But for example, on the second channel, this is still going on more than 1,000 milliamp hour, and so it's not that bad actually in terms of capacity alone. Maybe because of the internal resistance, the C rating or the constant current rating is worse, but this only dissipates an amp at the full charge, and we'll see why. Right, so why I have this mod is this kind of works. I started using it. I just plugged in a USB-C jack on this port that has two USB-Cs. So it has one USB-C up top and one on the other side, so left and right. And I plugged it on one of them and it worked, but it would only charge this side. And then I noticed the inscription at the back, which basically says one power supply charges one side of the cells. And this actually came in box with two power supplies. These are very Chinesium looking power supplies, and these are not good. There's no data pin resistance on these USB ports. So what that means is you can't just connect any run-of-the-mill Type C charger and expect it to provide 5 volts at 2 amps. So these charge at 1 amp each, so each side needs at least 2 amps. So you can't expect it to provide 5 volts at 2 amps through the USB port. And that becomes problematic because some USB chargers just don't provide anything if there's nothing on the data lines. So I ended up opening one of these, and as you can see, it's not a bad charger by design. There is an isolation transformer on it. It's a very hacked up one. So if you see the data pin right there are shorted, so it's still using a standard USB like power brick controller, but they've just shorted directly on the power supply. And I really didn't want to have two separate Chinesium power supplies running while I am charging and discharging lipos at a steady rate. So seemed too much of a safety issue. So I did something which, in my opinion, is safer, but people's um, perception of that might vary. I have here what is basically it's called a USB PD controller chip, controller board. It's from Kapuf, and it actually, you can just select dip switches right here and select the kind of voltage you want out. So because there's no spec in USB PD for 5 volts 4 amps, it only goes up to 3 amps. I set this to 12 volt. I set the USB PD decoder to 12 volts. So this, then I would make sure that your PD charger outputs 12 volts, and I put that 12 volt inside 12 volt to 5 volt step down converter, which does 4 amps, and that's wired directly to the PCB of this thing. And obviously, like, there's a lot of caution that goes through dealing with lipos, especially when you're putting them through so much stress. Is you don't want to just sit there and have it running unattended. So I have to babysit it. I always babysit it. It's been running for almost uh, 2 hours 45 minutes, and I have been here all the time, doing some other chores, getting some other work done, but I have been here and I've been monitoring it, making sure that this does not heat up too much, because it does not have any thermal sensors. It would be a really good idea to add thermal sensors and temperature monitoring to it, but again, this is not an expensive piece of kit. And the cells don't get as warm, but they do get slightly warm. As I said, it's supposed to draw an amp. It's supposed to design to constantly have a load on it, but that load is constant, not the current draw. What I mean by that is they just use 4 massive resistors to one. I'm guessing one for each lipo to act as load, and that's where the fan is sitting, just cooling those massive resistors. And if you look at through some light, you can see those resistors right beneath the fan. And so that's why, as the voltage drops, so does the current drop, because the resistance is static. Um, but that means if the resistance is static, then with the voltage the current will change. So it provides a constant load, not in the sense that it's providing like a constant current load, but it's providing a constant resistive load, which works out fine as long as it has the smarts to figure out how much the current draw is. It might even be a little bit safer where it's drawing slightly less current when the battery is at the lower voltage levels. So that battery is almost depleted. It's at 3.06. So it might reach 1200 mAh, might cut off before that. On the other side, this one's on the second charge loop. This one's on its last charge loop. Yeah, sometimes its loop calculation gets a bit messy. I haven't run it through the full 2 loop cycle, but seems to be okay. And like when it starts up, you can change the mode from auto to only charge or only discharge. So you can just press this button and you can select from all of those three options. So you can set the state or mode to charge only or discharge only or auto, where it goes through the loop. And then on stop, it has preset voltages: 3, 3.2, 3.4, 3.7, 4. So you can have different stop voltages. I think it even goes below 3. I haven't tested that, but below 3, you're basically destroying the cell, so I'm not a big fan of that. And then you can set loop up to I think 9 loops, which might be okay if you want to reform or like drain a very new battery. Um, but I don't really see a point of testing older batteries up to 9 loops. You will be degrading it a lot quicker. So that's about it. A short, quick video on this cool little doodad I bought from Amazon. Seems to be working nicely. I have a few more lipos to test. So as soon as all of these loops are done, I will go ahead, plug that in, and just mark on all of the lipos, throw away the ones that aren't healthy, and maybe I use it in the future to whenever I buy a lipo, just run it through a couple of loops and make sure that they are according to the manufacturer's spec. Not that I can do much about it. So that's about it. Let's see if in a few seconds this goes back to charging, and wait for it. It's at 2.99. It's supposed to stop any second now. Maybe it just touches 1200 milliamp hour. Nope, it's back at charging. So it just about made it. So it's 1197 milliamp hour. So not quite 2 amp hours. But which is interesting because these gray cells are rated to 2600. So it lost 600 mAh, but it still has most of its capacity. It's not that much, but still this one's very usable, although the internal resistance is quite crap. So again, so yeah, this will be charging it back up. It charges at an amp till 4 volts, and then it does trickle charging through 4.2, which is perfectly fine for 18650 cell. Let's keep this charging. That's one. So no, all right, the first cell's discharging at the moment. It's only made it till 664 mAh. So cool. Thank you so much for watching, and I will see you all in the next one.